For this lab, you have to configure OSPF on several routers. In this video, I'll go over that configuration, then I'll do a demo of the verification steps, a few in Cisco Packet Tracer and some in Cisco modeling labs. Let's jump in. So what about this lab? Well, the content matches topics you'll find in the official Cert Guide, Volume 1, Part 6, and it's Chapter 22 in the current edition. But the lab itself you'll find at this URL that ends in CLab 519. That's my blog. And the name is OSPF Interface Config 1. So what's there? Like with all these labs, they begin with the scenario and tasks. That is what you're supposed to do in the lab. Then a quick mention to say, hey, go do the lab. Do it in Cisco Packet Tracer or in Cisco modeling labs. And then there's an answer and explanation about the answer to close the blog page. However, I've got an intro video and a review video. This video is the review. If you haven't done lab yet, you probably want to check out the lab intro video first and then do the lab. This lab review video is to help you dig deeper into what you might have seen when you did the lab. Well, these labs are called config labs, so let's start by reviewing the configuration. And here's a reminder of the topology and the subnets and the interface IDs. Here's a more compressed version of the figure without the PCs in it. And the initial configurations in the lab, that is pre-configured information about all these IP address commands on the interfaces. Now, I put that here because I want to make a point. You could have looked at all that and done all that subnetting math and looked at the addresses, and you didn't need it at all to configure the lab. Yeah, it's useful to know that kind of thing and be ready for it on the exam, but in this case, here's the config on router R1. And none of the choices for these commands requires you to think about the IP addresses on the router interfaces. All right, so what do we have here? First off, look at the bottom. I located this part of the config at the bottom because that's where it will appear in the output of a show running config command. But here's the router OSPF command with the process ID number. You had to pick that, and the lab didn't tell you anything about what number to use. You could have used the lowest possible number of 1 or 2 or 3 or whatever. I picked 11. All right, it's pretty much pulled it out of my hat. All right. Then here's the important part. The interface subcommands that enable OSPF on the interface, by the way, the lab said use interface subcommands. So you'd use the IP OSPF process ID number command. That 11 has to match your router OSPF 11 command. This command matches the router OSPF command. This command matches the router OSPF command. All right, so that's the matching that has to happen all within this one router. So these IP OSPF 11 commands basically enable OSPF in each interface mode for the 3 interfaces. And oh, by the way, it ends in area 0 in the command, which says enable OSPF and place this interface in area 0. Remember how all interfaces were supposed to be in area 0 per this design? All wrapped up in one nice, neat, single interface command per interface. So there's your config. There was one other requirement to use router ID 1111 on this router, but to not rely on interface IP addresses, and that's how you'd configure it in OSPF config mode, router ID 1111. All right, so that's the router R1 config, and the config on router R2 and R3 is nearly identical. So if you look here on router R2, the lab didn't say what process ID to use, so I picked a different number to make this point. The process ID numbers don't have to match on nearby routers. Any number, as long as it's correct and matching within the one router. So here we chose, or I chose, OSPF process ID 22. So all the interface subcommands begin at IP OSPF 22 to match. All right, so that's the matching that has to happen. So enable OSPF, place the interface in area 0, enable area 0, enable area 0, and by the way, make this router's router ID 2222. Now, even if you hadn't answered like this, you probably can guess what router R3's config would look like now, right? You pick some process ID. I picked yet a third number just to make the point that they don't have to match. You could have made them all 1 on all 3 routers. That's fine, but I made this one process ID 33, so my 3 subcommands begin IP OSPF 33, ending in area 0, again, placing all the interfaces, all 3 interfaces, in area 0. And while in router config mode down here, I added the router-id command, giving router R3 router ID 3.3.3.3. Besides configuring OSPF, it's probably useful to go verify a few things, right? So here's a reminder of the topology, and here's some suggested tasks. Confirm on all three routers that the router IDs you intended are the ones that OSPF is really using right now. Each router should have two OSPF neighbors. R1 should be neighbors with R2 and R3, R2 with R1 and R3, and so on. Each router should learn 3 OSPF routes, or routes to 3 subnets using OSPF. For instance, router R1 here will learn a route to R3's LAN subnet and R2's LAN subnet, as well as this WAN subnet that R1's not connected to. And then, because the config was really about enabling OSPF on interfaces, go to R1 and make sure OSPF is enabled on all 3 interfaces. Go to R2 and ensure the same thing. So those are some things you could try in lab, and I'm going to do it here in a demo. So here's the packet tracer file opened, and I've configured the answer config. So basically copy and pasted the configurations that are the answer into each of these devices beforehand. So here we're at router R1, and let's just look around at a few things. I'm going to glance over here at my notes to be a little more systematic about it, but let's check out the OSPF router IDs. And show IP OSPF tells you the router ID right in the top line. So R1's using 1111, for instance. You can also see that with a show IP OSPF database command, OSPF with ID 1111 right up there at the top, all right? So the configuration should have just had that router ID command defining 1111 as the router ID. Then OSPF neighbors, show IP OSPF neighbor is the shorthand command. So you don't have to use the word brief, just show IP OSPF neighbor. And we see one each. We see the neighbor router ID of 2222 and 3333. So that's another confirmation that the neighbors are configured to use the router IDs that we intended for them to use. If you want more detail about those neighbors, show IP OSPF neighbor detail. And now you get basically a stanza or so of messages about each neighbor, and the neighbors are identified by their router IDs. So there's neighbor 2222 and neighbor 3333. All right, what else do we want to verify? We wanted to verify routes, right? So show IP OSPF, show IP route. I hit the space bar to get the rest of that out here. And per the legend, C are connected routes, and O are OSPF routes. So here we see an O and an O and an O. So those are our 3 OSPF learned routes. This route is to subnet 172.22.20. That's R2's LAN subnet. This one is to 172.23.30, which is R3's LAN subnet. And this one is to the WAN subnet between R2 and R3 that R1's not connected to. And it turns out it's got forwarding instructions out both links because the metric ties both through router R2 and router R3. So we've got 2 next hop options for that route. All right, so we've got the 3 OSPF routes we would expect to learn. And then just to make sure OSPF is enabled on the interfaces we thought it would be, we could do a show IP OSPF interface brief command, which gives us a single line each. And we see the interfaces on which OSPF is enabled. We see the OSPF process ID of 11 that we went over before. So there you go. And by the way, there's the area number they're assigned to. So process ID 11, area number 0. If you did that same command but left off the word brief, you'd get a stanza of lines per interface. And just to scroll up here, we'd see, hey, there's gigabit 0. And the fact that it's listed here means it's enabled for OSPF. One last thing while I'm demoing here in Cisco Packet Tracer here on router R1, the show IP protocols command lists output that's not quite correct in this case compared to real gear. When you're configuring using those interface subcommands, you would normally see some other messages up in here, including a list of all the enabled interfaces. That is, all the interfaces enabled by that IP OSPF interface subcommand. In the CML demo I'll do in just a few minutes, you'll see that and see the correct output. You can also do some verification from those endpoint hosts, for instance, do pings and trace routes. In this case, I've updated the figure to show the specific IP addresses of those 3 PCs. You could connect to each of those and do commands like these: trace route to the PC 2 and 3 from PC 1, from PC 2, trace route PC 1 and 3, and so on. By the way, in Packet Tracer, the command on the PCs is trace RT instead of trace route. Now, when you're done with that testing, if you're using Packet Tracer, you're done. You can stop watching the video. But if you're using CML, I've got a little bit more of the video to give you some hints and tips and a little more demo of what you can do with CML. So let's talk about a few things with CML. First off, the interface IDs can't be identical, but they're pretty close. Instead of gigabit whatever, they're Ethernet whatever. So all the gig 00s are E00s, because they're only Ethernet interface type. All right, so it should be pretty easy to correlate. The really tricky part is that instead of those 3 separate PCs to deal with the 5 active node limit in CML-Free, I've replaced them with one router that's going to act like all 3 of those PCs. And I call that router the router as many hosts router. And here's the deal. So let's just say we wanted to use a ping command and we wanted to ping this router IP address, R1's gig 00 IP address. Well, we could do that from this one router as many hosts. All right. And what you would do then is get into the console of that one router and do ping VRF host 1 to mean ping as if I'm host number 1 in this design. And then there's our destination IP address. So where would that packet go? It would go from that router as many hosts as if it was PC1 into this LAN to R1 and back. But if instead at that same console of the router as many host router, you did ping VRF host 2 to that same address, it would come in as if it was plugged in where PC2 was, come into router R2, who would use its OSPF learned route to forward the packet over to R1. R1 would reply, send it back. It would flow through the network just as if PC2 was really there and sending the packets. Same deal with a ping VRF host 3. Ping as if you're host 3, flows up here and back. Or with traceroute commands from PC1, traceroute VRF host 1 means traceroute as if you are host 1. From PC2, traceroute VRF host 2, meaning traceroute as if you're host 2, and likewise for host 3. So let me show you a quick demo of how to do that. So what I've done is imported the CML file and performed a lab so it's all configured to what I think is correct. And in the dashboard, I'm going to see this diagram with the 3 routers that are the routers that you configure, 3 switches that are unmanaged switches so they don't count against the 5 active node limit, and this one router as many hosts router. All right, and that's where we're going to test our commands from. But if I open up the console window, and of course, there we go, and I press return, I've pre-configured that router as many hosts so it does its thing, and I've created a banner. And you see this banner that goes here. It's got a lot of good notes, so if you're using this tool, read it, and it reminds you of the command syntax of acting like each of the hosts in the lab, and it reminds you that if any passwords are needed, they're either simply Cisco, or if it's a username and password, it's Cisco and Cisco, all lowercase. Like below, it's waiting on a username, so I'm going to type Cisco, and then password Cisco, and I'm in. Why did I set up passwords here? So that you could test with Telnet and SSH into this device as well for additional testing. So here's my prompt with the host name R as many hosts, and just for grins, I'll go ahead and get into privilege mode. So if I wanted to do those traceroute commands that we just talked about, here's what I could do. Traceroute, but I don't just plug in the IP address next. I want to say VRF host 1. Meaning traceroute as if I am host 1 for this test. And we're going to go to PC2, which is 172.22.2.3. And now we're seeing the response from the traceroute. And if you look down there, you'll see 3 addresses. The first one is R1's LAN address. The next one is R2's WAN address. And the final one is the destination host, PC2. Now you could up arrow and retrieve the command and change the destination address to PC3's address of 172.23.3.4 and do that. And we get the same kind of output. You could get the diagram out and trace where you think the addresses are, but that goes to R1's LAN address, R3's WAN address, and then to PC3 and back. Now from this same console, you can do commands to test as if you're PC2 or PC3, like traceroute. And then we give it VRF host 2. Ping as if you are host 2. So it will enter the network into that switch 2 and then into router R2. And let's ping a destination of PC1's address, which is 172.21.1.2. Let me check. Yep, that's it. And there's a trace route, comes into router R2's IP address, then router R1's WAN address, and then to PC1 and back. And we repeat it and change the address to PC3's address, 23.3.4. Again, we see output. So it's a nice way to test things. So I want to show you one more thing about some differences between CML and packet tracer. I mentioned this in the packet tracer part of the demo. But in particular, the show IP protocols command in packet tracer in the current version, which when I recorded this was version 8.2.2, isn't quite correct. Now I'm going to highlight this section, and the heading line of this section is routing on interfaces configured explicitly. And then indented from that are the three interfaces that you configured the IP OSPF command on, Ethernet 0/2, 0/1, and 00. And that's what that section means. It means these are the interfaces on which you explicitly enabled OSPF with the IP OSPF command. So it's a great way to confirm what you really configured. That's just missing in the packet tracer version of this output. So that's one reason why you might want to say, hey, I'm not quite happy with not getting to see that in packet tracer. Let me go try it in CML and see that. And another one, I don't know that I mentioned it in the demo, but show IP OSPF interface brief. We see a list of the three enabled interfaces over here on the far left, Ethernet 02, 01, and 00, but on the far right, we see a count of neighbors in BRS, all right? Turns out packet tracer doesn't show accurate counters for those, whereas CML, since it's running the real operating systems, is much more accurate in such things, and it shows that on the two WAN interfaces, Ethernet 02 and 01, we know R1 knows about one neighbor each. Hey, hope you enjoyed this Config Lab review video. If you look, you'll see a couple of videos popping on the screen. You can check out some more instruction on another OSPF topic, or maybe check out another Config Lab video. Hey, thanks for hanging out. Talk to you soon.